Okay guys, welcome back to our channel. Basically today we want to run through some JAMB topics. Right, JAMB is barely 24 hours from now, so this class is more or less like a 9-minute class. Of course, it's going to be of help to some persons. All right, so we just want to run through some topics in JAMB. Trust me, it's going to help you out. So the first topic we want to talk about is chemical equilibrium. Now, under chemical equilibrium, what do we need? First, we need definition of term. All right, we also need factors that affect equilibrium, Taylor principle, okay. So the first thing here, we want to talk about definition of chemical equilibrium. Right, class, what is chemical equilibrium? Right, chemical equilibrium is a state where the rate of the forward reaction is equal to the rate of the backward reaction. I repeat, chemical equilibrium is a state where the rate of the forward reaction is equal to the rate of the backward reaction. All right. Now, what are the properties of equilibrium? Number one is that a reaction that is in equilibrium has to be dynamic. Dynamic simply means it has to be moving, right? You know, in physics, we also have equilibrium, but that of physics is static equilibrium. But in chemistry, we have dynamic equilibrium. It is always in constant motion. Now, the next property we're going to be looking at is not really a property, but it's important that we know it. There's what we call reversible reaction. Remember we said chemical equilibrium is a rate at which the forward reaction is equal to the backward reaction. So this is always represented using two-head arrow. So we have something like this. Now this simply means that the rate at which this guy is going forward is equal to the rate at which this guy is going backward. So this is basically what we mean by reversible. So if I have A equals to B, so this is actually equilibrium reaction, right? So this B is forming at the same rate as A. Now, the next thing we need to talk about is equilibrium constant. Equilibrium constant. Now, equilibrium constant has a symbol of K. Class, anytime a reaction is reversible, like this, anytime you see a reaction that has these two arrows, right, it means that that reaction is in equilibrium. And for every reaction that is in equilibrium, there has to be equilibrium constant, right? So how do we write equilibrium constant expression? Basically, I will tell us. Equilibrium constant expression is a ratio, right, of the product concentration to that of the reactant. So for this reaction now, let's say this reaction has a stoichiometric coefficient of A, and this guy has a stoichiometric coefficient of B. Equilibrium constant for this reaction, which is K, is equals to, when we say ratio is more or less written like a fraction, right? So we say the concentration of B, use a square bracket, because this square bracket denotes concentration. Now, this is going to be concentration of B because it is the ratio. Equilibrium constant is defined as the ratio of the concentration of the product to that of the reactant, each of them raised to their stoichiometric coefficient. So the concentration of the product is B, so I'll put square brackets. The coefficient of B is small letter b. The reactant is A, the coefficient of A is small letter a. So this becomes the equilibrium constant for this reaction. What if they gave us something like this? What if they had given to us, let's say, H2 plus N2, giving us NH3. So we put this guy 2. Now, for this reaction, imagine you were given something like this, and you're asked to write equilibrium constant expression for this. This will simply be K is equals to, now the product of this reaction is this ammonia, right? So I'll say, put a line, the product is ammonia. Please remember, it is concentration, so that is why we are putting this square bracket. Now, the concentration is why we have this square bracket. Now, raise to the power of 2, which is the coefficient, all over hydrogen is a reactant, the first reactant, times nitrogen. Now there is nothing here, so this is assumed to be 1, so that is what we have here. So this is equilibrium constant expression for this reaction, right? So most of the times in exams, they will give you a reaction and you're asked to tell if that equilibrium constant is correct. So that's how we got this, okay? So the next thing we're going to be talking about is we're going to be talking about a rule or a principle that guides a reaction in equilibrium. In chemistry, virtually we have rules guiding almost every reactions or every calculations, right? So in chemical equilibrium, the law or the principle guiding chemical equilibrium is what we call the Le Chatelier principle. Right? This principle states that if a system in equilibrium is disturbed, right? Now the equilibrium is going to adjust to cancel out the effect of the disturbance. I repeat, Le Chatelier principle states that if a system at equilibrium or in equilibrium is disturbed, now this disturbance could be in terms of change of volume, change of concentration, or change of pressure, right? If a system in equilibrium is disturbed, right, it states that if a system in equilibrium is disturbed, the equilibrium is going to adjust itself so as to cancel or annul the effect of the disturbance. Right. Now, this is what I mean. For example, if I have, let's say, I have a bucket of water here. Now, let's say we have a bucket of water. Now, with this now, I have, let's call this guy reactant. Let's call this guy the product class. I have created an equilibrium system with this diagram. Now, what this simply means that at every point in time, the water level in this two tank will always be the same. That is what it means. The water level here, as long as there is a pipe joining these two containers at the bottom, right? These two is in equilibrium. The water level will always be on the same level. So if you put 10 liters of water on the left-hand side initially, after you finish putting the 10 liters of water, it will share itself 5, 5, right? Now, what this simply means is that I have formed an equilibrium. So if I should disturb this equilibrium by taking out water, either from the reactant side or from the product side, you realize that this system is going to readjust, right, to form a new equilibrium. Now, this is what I mean. If I remove 2 liters of water from here, this 5 reduces to 3. But the interesting fact is that this cannot be 5 and this guy will be 3. So what is going to happen here is that 5 plus 3 is 8, right? So this guy will readjust so that here will now become, okay, let's say this guy will release 1 liters of water and put to this side. So this guy increases to 4 and this guy decreases to 4. So in that case now, after taking out 2 liters of water, this readjusts and forms another new equilibrium. It means that at every point in time, both of them will always have same water level. That is what it means, right? So when we say when a system is disturbed, disturbance in this case is not using cane to pursue the person. No, it's basically either you increase the concentration, the pressure, or the volume. But in today's class, I'm just going to be talking about 2 factors that affects chemical equilibrium. All right. Now, Clara, listen, right? The 2 major factors we have, number 1, concentration. Number 2, pressure. So let me summarize this. Remember what that explanation I gave to us earlier? Imagine I have something like this. So let's call this guy reactant. Let's call this guy reactant. And let's call this guy product. Class, look up. What this thing simply means is that if I have it to be 5 liters, here will also be 5 liters. Now, what will be the effect of change in concentration on equilibrium? Now, change in concentration simply means, are you increasing the concentration of the reactant, or you're decreasing that of the reactant? Or are you increasing that of the product, or you're decreasing that of the product? Now, let's use this for example, or for illustration so that you understand. Let's assume this system is in equilibrium. The left-hand side is a reactant, the right-hand side is a product. Right, class? If you remove water from the reactant, if you take out water from the reactant, you realize that the flow of water will from the products and return back to the reactant. This is what I mean. Imagine I take out 2 liters of water from here. This place reduces to 3. The water level are no longer balanced. So in order for us to balance this guy, 1 liter from the product will go back to the reactant, so that here becomes 4 and here becomes 4. Now this simply means that if you decrease the concentration of the reactant, which is equivalent to removing the water on the reactant side, decreasing the concentration of the reactant shifts equilibrium to the back. Shifts equilibrium to the back. Now, what are the two things can make this equilibrium position? Because in exams they will ask you increase in pressure or increase in concentration will shift equilibrium to which side? Is it to the left or to the right? So it's best we understand this concept so that it will help us better, right? So if I remove water from the left hand side, listen, this left hand side volume will decrease. So in order for us to actually attain a new equilibrium, water will flow from the right to the left. Right? Now, let's return back. What else can make this guy move from right to left? Class, if you decrease the concentration of this reactant, which is equivalent to removing the water on the reactant side, the water will flow from right to the left. Now, if you add additional water to this guy, let's assume I add 2 liters of water to this. So here now becomes 7. Class, it is not possible for here to be 7 and here to be 5. It's not done. So once you add water here, this extra 2 liters that you added will be shared. This is 5. This is 6. In other words, class, listen. Decrease in concentration of a reactant or increase in the concentration of the product will shift equilibrium to the left. We will shift equilibrium to the left. Conversely, increase in concentration of the reactant and decrease in the concentration of the product will shift equilibrium to the right. But I don't usually advise students to note both ways. Just perfect yourself in knowing one of the ways, and obviously opposite becomes the other one. Because if you're trying to say increase in this goes to the left, you might confuse it. So just pick one. Decrease in concentration of the reactant or increase in the concentration of the product will shift equilibrium to the left. Obviously, vice versa will now be to the right. So that is the concept behind effect of concentration on equilibrium. Now, let's look at pressure. Class, pressure is, according to Boyle's law, pressure is inversely proportional to volume, which means that if pressure increases, volume will decrease. That is what it means. Or if volume increases, pressure decreases, vice versa. So how does pressure affect equilibrium? I'll tell us. Now, anytime you increase pressure of a reaction, increase in pressure means decrease in volume. So basically, if pressure is increasing, the equilibrium direction will shift towards the side that will have smaller volume. So if, for example, I have H2 plus N2 giving me 2NH3. Assuming I have something like this. This is the reactant side, and this is the product side. Now, if I increase pressure, the law says increase in pressure leads to decrease in volume. Class, in these reactions, these are all gases. Volume can be seen as mole. So this reactant, the number of moles on the reactant side is 3 plus 1 because there is invisible one here. 3 plus 1, which is 4 moles. Now this 4 moles is equivalent to 4 volume. On the product side, we have 2 mole, which is equivalent to 2 volume. So you notice that the product has 2 volume and the reactant has full volume. So between these two sides, which of them have lesser volume? The product side. So remember, if you increase the pressure, volume decreases. So for this particular reaction, increase in pressure will shift equilibrium to the right because the right hand side has lesser volume. What if I decrease the pressure? If I decrease the pressure, volume will increase. So decrease in pressure will shift equilibrium to the left, the side that has more volume. So with this particular summary of chemical equilibrium, you should be able to answer any question pertaining to chemical equilibrium. As simple as that. So if you have any question, please drop it on the comment section. Thank you.